Welcome back to Week 6 of CYB530, Securing and Administering Windows. This week, we will talk about Active Directory and Group Policy. But first, let's take another look at the materials from the previous week.
As we have already seen, in a Windows environment, the principle of least privilege is implemented at the user account level. In fact, Microsoft refers to user accounts that were created using this principle as least privilege user accounts, or LUAs. Now, with these accounts, all Windows users are associated with one or more groups. And the majority of permissions in the Windows environment are in fact controlled at the user group level. A common and manageable way to implement least privilege is to create these user groups that represent roles in your organization. Every organization is different, and there are many options for creating roles, of course. So the table here shows just a few examples of common groups that are built during system install as default in older versions of Windows Server. These are the common roles within an organization, and they are a good starting point, but only a starting point, which means that they do require refinements and additions based on what your individual organization looks like. Server 2016, in fact, adds to these basic default groups a multitude of other groups called security groups, and those are really useful for implementing least privilege. So now let's talk about groups and access control. Each group in Windows has the ability to apply rights and permissions to sets of users. Associating users with one or more groups then allows the implementation of least privilege in a group setting. That is in contrast to configuring each individual user account. So securing groups instead of individual users makes the goal of least privilege far more feasible, especially if you have a lot of users in your network. Typically, you define and maintain user rights through group security policy objects, and we'll dive into those in the next module. Permissions apply to specific objects and are maintained through each object's security settings. So by defining a list of access control rules for each object, you actually define access permissions for specific users or groups. This list of access permissions is called the access control list, or ACL, for the object. Since the ACLs that Windows uses are implemented as discretionary access control, they should actually be called a discretionary access control list, or a DACL. But who has the time for an even longer acronym? Anyway, each entry in the DACL is called an access control entry, and that's an ACE, or sometimes also called ACE. The process of securing resources in Windows then starts with creating object DACLs that satisfy your security goals. And here on the right side of the slide, you see a DACL for a Windows object called test. As a reminder, here's how identification, authentication, and authorization work, both for local users on the left side of the slide and for Active Directory users on the right side of the slide. First, Windows prompts the user to enter identification and authentication credentials in the form of a username and password, or a token password entry, or a biometric entry from a fingerprint reader, and the like. Then Windows looks up the defined user and the associated authentication information. And if the supplied information matches the stored information, the user is authenticated. Once a user has been authenticated, the operating system records the user account's security identifier, or SID, and the SID of each group to which the user is assigned in one or more tokens. The token that Windows uses to store all the SIDs is called the Security Access Token, or SAT. The SAT, then, with all the user and group SIDs, is attached to each process that the user runs. Now, all of these steps on the left side of the screen here are specific to a computer in a standalone or workgroup environment. Now remember that workgroups do not share users or groups. So as users and group settings and assignments are customized, synchronizing changes across computers in a work group becomes really difficult. This is where Active Directory comes in. Active Directory, on its domain controller, stores the shared necessary information to construct SATs, which are identical for a given user, regardless of the computer from which the user logs on. But then, if the domain controller sends security information to the computer where a user logs on, how does Windows stop an attacker from intercepting the SAT information and impersonating an authorized user? This is where Windows extends the concept of authentication to the computer level when constructing SATs. That's what you see in the middle of the Active Directory user screen here. The complete SATs or SATs are never shared across the network, only the parts necessary to construct the SAT. The domain controller stores the domain user's SID and the SIDs for all of the domain groups to which the user is assigned. The target server, which is the server where the resource access resides, already has the local group list of groups to which the user is defined and the local user rights definitions. Then the domain controller sends the domain user and group SIDs to the target server using one of two Windows authentication protocols. As we've seen, a secure information system depends on a secure strategy. Here's one way of ensuring a best practice that focuses on solid planning and allows you to implement a manageable approach to both subjects and objects. It's called AGULP. AGULP stands for Accounts, Global Groups, Access Controls, Local Groups, and Permissions. The idea behind AGULP is to systematically nest individual user accounts in groups so that securing objects becomes more general. So the first step is to create separate user accounts for each user. That adds an extra step of security. Then you add those user accounts to global groups based on their shared attributes. These groups can be geographical, like Western US, Eastern US, or functional, like manufacturing or human resources. You then add these global groups to the groups that you have defined for users in your Active Directory domains. Next, you add those Active Directory groups to local groups on the machines that contain the resources that you want to secure. This allows you to dynamically, by using the global groups, add individual users to local groups. Finally, you define the permissions for the secured resources or for the objects for the local groups. So this AGULP strategy allows you to reduce the number of ACLs for each resource. But regardless of the strategy you decide to use, whether you decide to use AGULP or not, you should avoid defining ACLs for individuals because these group-based ACLs are much easier and much more efficient to maintain.
And now let's get started with our discussion on group policy and Active Directory.
In this module, we will define group policy and group policy objects by themselves and in the light of your overall security policy. Then we will look at GPOs in the Windows Registry and in Active Directory and discuss best practices for designing and applying group policy controls. The Windows Group Policy feature is a centralized set of rules that govern the way Windows operates. It gives you the ability to define and apply both general and security-related configuration changes to one or more computers. You can define both local group policy settings and group policies in Active Directory. Local group policies control the behavior of a single computer. Active Directory group policies can apply to any users on any computers defined in Active Directory. Using group policy can make administration tasks easier than having to write scripts or individually secure basic security settings. GPOs make it easy to enforce standard behavior across multiple users or computers, as we've already seen. For example, GPOs can easily set firewall settings on multiple computers, define consistent desktop layouts, run scripts when users log on and log off, and redirect folders to network folders. And these are only a few uses of the GPOs. So when booting a computer or logging on, Windows looks up and applies the GPOs for that computer and that user. Group policy uses a pull technology, which means that Windows periodically searches for any updated GPOs. If it finds a new GPO, it downloads and applies the changes to the existing environment. By default, Windows checks for new or updated GPOs at a random interval from 90 to 120 minutes. This automatic update feature ensures that Windows applies any new or updated GPOs often without requiring that users log off or reboot computers. As of Windows Server 2012, we can now force GPOs to refresh on all of the selected computers within less than 10 minutes. This new feature is called the Remote Group Policy Update, and it makes deploying GPOs easier and a whole lot more dependable. Microsoft publishes a handy-dandy spreadsheet listing all of the group policy settings that are included when installing one of its operating systems. That is because Microsoft includes several template files with each Windows version in which a lot of settings are defined. This spreadsheet can be found by visiting the downloads area of Microsoft.com and searching for Group Policy Settings reference. Microsoft gives you several versions of the spreadsheet to cover different Windows releases. And this reference contains descriptive information that you can use to create and modify the GPOs to meet your organization's security needs. Here at the bottom, we see an excerpt from this file. Here is an example row from this document. As we can see, this password policy is supported from Windows XP SP2 onward and Windows Server 2003. It is not included in any registry settings. And here is the help text that defines the group policy. It also shows whether a reboot is required or not. You can configure these policy settings when you edit the group policy objects. Group policy objects can define many settings. Here are a few of the more common settings. We're starting with the password policy, which sets the requirements for password strength, age, history, and how Windows stores passwords. Then we can also define an account lockout policy, which describes how Windows handles accounts locked after failed login attempts. Another popular GPO is the Kerberos policy, which sets the lifetime limits for Kerberos tickets and clock synchronization. And then we have the audit policy, which defines the events that Windows records in the audit files and that we can later access through the event viewer. Of course, we have a policy for user rights assignment that describes the individual user rights that define what general actions users can perform. For example, access this computer from the network or change the system time. And then we have security options. Security options defines what security-related actions users can perform. For example, allow to format and eject removable media or require a smart card. And the event log GPOs define the maximum size and the retention settings and the guest access settings too for the event logs. The restricted groups GPO lists the users in security sensitive groups and to what other groups the restricted group can belong. Then we have the System Services GPO, which defines the startup mode and access permissions for system services, and the File System GPO, which defines access permissions on discretionary access control lists, the DACLs, and the audit settings for system access control lists, SACLs. You can link these GPOs to specific users to customize settings for group users or even individual users. Users who log on anywhere in the Active Directory domain will get GPOs linked to their user account. You can also link GPOs to organizational units. This is what we will do later. In fact, you must link GPOs to at least one computer, domain, or organizational unit for the GPO to be active. GPOs that aren't linked to a computer, domain, or OU are defined, but they're just inactive. You can define OUs to logically group computers into functional groups, which is what we will do in the later part of this module, such as IT, HR, and finance. And once you define one or more OUs, you can add computers to each OU to logically group them together. Then when you link GPOs to OUs, Windows will download and apply only the appropriate GPOs for the computer and the user logging on. For example, you may define a desktop with icons related to HR applications for the HR OU, or certain printers that are in a certain office. A user who logs on to a computer in the HR OU then will see the desktop specific to human resources and be able to access the printers specific to their geographical location. Users who log on to a computer that is not in the HR OU will see a different desktop and have access to different printers. At this point, we should really talk about how to align group policy with your organizational security policy. As we know, group policy is a functional feature of Windows, but it has little meaning by itself. It is a mechanism used to apply controls that enforce your security policy. For example, should you set a maximum password age for all the computers in your environment? The answer is, it depends. Setting a maximum password age is generally a good idea, but not something you should arbitrarily enforce. This is where your security policy should direct any settings you add to GPOs. In fact, the GPO you define and use should conform to your security policy. There are two main reasons for making group policy conform to your security policy. Number one, to allow management to meet security responsibilities. And number two, to ensure that there are no gaps in your security policy and your policy doesn't contain any additional controls. First, your organization's culture should provide guidance on interpreting the security policy. A strict security policy interpretation means that no security controls exist unless they are directed by the policy. A less strict interpretation is more common. It allows IT security to exercise some discretion to implement best practices that may not be exactly and explicitly defined in the security policy. Second, your group policy definition should satisfy your security policy goals and not add any arbitrary controls. Your primary goal for designing group policy should be to ensure your group policy does not leave any gaps in your security policy. The GPOs you create and implement should meet all the goals in your security policy. It shouldn't add any controls that are not covered in the policy. When your environment's group policy conforms to your security policy, you create a validation method of your security policy. You can record the existence and performance of GPOs as evidence that you are complying with your security policy. So, making group policy conform to your security policy is a three-step process. You first want to examine a list of GPO settings that already exist in the default Windows templates. The Group Policy Settings reference from Microsoft is an excellent resource for this task. So identify any GPO settings that satisfy parts of your security policy. Activate all settings that are appropriate for your policy. The second step is to identify any elements in your security policy that do not already exist in default Windows templates. Then you would list the elements that new GPO settings can address. For example, suppose you want to hide the recycle bin on every user's desktop. You can easily create a new GPO with this setting. The third step in making group policy conform to your security policy is to create new GPOs for each of the remaining goals in your security policy that you identified in the second step. Here are a few strategies that can help you save time in developing an effective group policy. When you create GPOs, don't put too many unrelated settings in them. Define GPOs only for a small number of related settings. That way, you can use the GPO for several different uses. You also want to create organizational units or OUs to define logical groups of computers. It is often convenient to define and deploy GPOs to OUs to manage groups of computers. And then you really want to use all of the available Microsoft resources and tools to avoid wasting time and effort. These resources include the Group Policy Best Practices Analyzer, which helps you identify group policy configuration errors or dependency issues that may prevent settings from functioning as you expected. Then there's the Security Compliance Management Toolkit that includes resources that will help you plan, deploy, and monitor the security baselines of servers from Windows Server 2008 onward. Lastly, the GPO Accelerator is really useful because it helps you automatically deploy the recommendations in the Security Compliance Management Toolkit. The security guides in the toolkit recommend group policy configurations and security template configurations that can be easily enforced with Active Directory domain services. Group policy allows you to define the specific targets for each rule. Some rules on your security policy apply to all users on all machines, while others do not. For example, the rule all users must create passwords for user accounts that conform to the strong password policy applies to all users. On the other hand, the rule members of the database administrator group must change passwords at least every 90 days applies only to users who are members of the database administrator user group. Windows provides you with the ability to specify GPO scope, which defines how Windows enforces security rules. Active Directory provides the ability to define group policy at different levels. Windows looks up all applicable GPOs when a computer boots or a user logs on. It then applies multiple GPOs in the following order. First, it applies the local GPOs that are defined and stored on a local computer. Then it defines the site GPOs that are defined in Active Directory. After that, it applies the domain-wide GPOs that are defined in Active Directory, and then, lastly, the OU GPOs that are defined in Active Directory. This means that any setting in a higher level GPO will override a lower level GPO setting. For example, a setting in a domain GPO will override a conflicting setting in a local GPO. This behavior applies only, though, if a GPO setting contains a specific value. If the higher level GPO setting value is not configured, then Windows applies the value of the lower level GPO setting. Creating GPOs that conform to your security policy enables you to validate and evaluate each part of this policy. You'll learn later how to list and audit GPOs. Reporting on GPOs makes it easy to evaluate how well your organization is complying with your security policy. Windows stores many group policy settings in the registry. The registry is a database on each Windows computer that stores configuration settings for the computer and for the users. The Group Policy Settings Reference spreadsheet lists the key locations for settings stored in the registry. The registry stores group policy settings either in HKey current user or in HKey local machine. HKey current user keys define settings that are specific to each user, and HKey local machine keys define settings that apply to the computer, regardless of who's logged on. Here we see a line from the Group Policy Settings reference stored in HKey local machine that enables the machine to format and eject removable media such as CDs, DVDs, USB drives, and the like. As we have seen, there are two main types of group policy settings. There are local group policy settings and Active Directory group policy settings. We'll start with the local group policy settings. You define these on each computer, and Windows stores the settings on that very computer. This also means that all of the local group policy settings apply to just that computer. When you first open the local group policy editor, and you can do so by typing gpedit into the Run window here, you see the two main groups of settings, computer configuration and user configuration. The settings under the computer configuration category are stored in the registry under the HKLM, LM for local machine entry, and the settings under user configuration are stored in the registry under HKCU, which is current user entry. Although the Windows Registry Editor can be used to modify group policy settings, the local group policy editor is a whole lot easier and it's a whole lot safer too. The local group policy editor allows you to change only the local group policy settings, and it ensures that the settings are stored properly and in the correct location in the registry. Changing group policy settings in the local group policy editor is easy. Find the setting you want to change, choose Edit, and change the setting to the value you choose. The screenshot here shows the modified value for the camera setting new in Server 2016. When you enable this setting, users will be able to use any camera device connected to the computer. That can, of course, be useful for web conferencing, but in a government context, it might as well be disabled for information protection purposes. Since group policy settings are stored in the registry, they can theoretically be edited directly using the registry editor. You should really not do that. Windows stores all currently active GPOs in the registry under the HKCU entry, so that when a user logs on, and every 90 to 120 minutes after that, Windows will update the HKCU drive with the most current GPOs that apply to the current user. This update will also occur within 10 minutes if a Windows Server 2012 or later computer refreshes the GPOs with a remote group policy update. Each GPO has a globally unique identifier, the GUID, that uniquely identifies it as a Windows object. The GPO GUID is the key Windows uses to store the GPO in the registry. That's what we're seeing here under Group Policy Object for Machine and for User. Windows stores current GPOs under the key HKey current users, software, Microsoft Windows current version, group policy objects. This is the path here. Here we see the GPO setting for allow use of camera from the previous example in the registry editor. Although defining local GPOs provides positive control over single computers, the real power of group policy is in Active Directory. Defining GPOs in Active Directory gives you the ability to centralize security rules and control how Windows applies each rule. You create Active Directory GPOs on a domain controller. Windows stores these GPOs in Active Directory in such a way that the domain controller automatically replicates the GPO to other domain controllers. This feature reduces the workload of administrators because it relieves the need to define security rules on multiple computers one at a time. Here we see the Group Policy Management Console, or GPMC. Active Directory GPOs are created on the domain controller using this Group Policy Management Console. It looks a lot like the local group policy editor, but allows you to do far more than just create GPOs and maintain their settings. Here's a list of some of the actions you can perform in the GPMC. You can create and edit GPOs, you can import and export GPOs, copy and paste them, back them up and restore them. You can search for GPOs, and you can create reports on GPOs. So, although there are multiple ways to create GPOs, the most common method is to create GPOs under the desired domain in the GPMC. New Active Directory GPOs don't actually do anything until you link them with some entity. And we'll learn about GPO linking later. Windows stores Active Directory GPOs in a folder on the domain controller. Computers that are in a domain retrieve all the GPOs that apply to that computer when a user logs on using a domain account, or when a computer connects to the domain. The domain controller searches for the appropriate GPOs and sends them to the computer. Of course, the computer and user must first successfully authenticate to the domain controller. Then, every 90 to 120 minutes, the remote computer asks the domain controller if any GPOs have changed. If they have, The domain controller sends the new or updated GPOs and the remote computer applies them. The domain controller, as we can see here, stores Active Directory GPOs in a folder named Policies. Windows creates a Policies folder for each domain. It stores each GPO in a subfolder under Policies. The name of each subfolder under Policies is the GUID for the GPO. You can navigate to the GPO in Windows Explorer and see where Windows stores the GPO settings. Each GPO folder, also called GPO shell, contains two subfolders. One of them is named Machine, the other one is named User. These subfolders contain the GPO settings for both the machine-wide and user-specific settings. Each subfolder contains policy files for defined GPOs that apply to a domain. Unlike local GPOs, Active Directory GPOs do nothing until you link them to one or more containers. An Active Directory container can be a site, a domain, or an organizational unit, OU. The Group Policy Object section of the GPMC lists all defined GPOs. You can edit existing GPOs or add new GPOs. You must link GPOs to one or more sites, domains, or OUs to make the GPOs do anything. How to link a GPO is what we can see here. A single GPO may be linked to multiple containers, and each container can have multiple GPOs linked to it. The easiest way to link GPOs to containers is from the context menu of the container. One of the most important considerations when designing GPOs is efficiency. You want to define and link the minimum number of GPOs to satisfy your security policy. Creating too many GPOs will increase the time and effort you'll need to administer and maintain your security policy. Having too many GPOs also increases the possibility of errors and opportunities for hackers to compromise your systems. The simplest environment would be one in which you define one set of GPOs that applies to all computers and all users in all domains. Unfortunately, few environments end up being that simple. Functional demands often require different controls for various computers and users. You can define several layers of GPOs that work together to ensure you enforce your security policy for all computers and all users. Windows gives you the ability to create high-level GPOs that enforce large-scale security settings, and more specific GPOs that allow you to fine-tune settings for specific situations. Recall from earlier in this chapter that Windows applies GPOs in a specific order. Knowing this order lets you put more generic settings in GPOs that Windows applies first, and more specific settings in GPOs that Windows applies later. Recall that Windows applies GPOs in this order: first local GPOs, then site GPOs, then domain GPOs, and then GPOs for the organizational unit. You want to design your GPOs with this order in mind. Since Windows applies the OU GPOs last, any global GPO settings should go here. Identify any settings you want to enforce for all computers and users and define GPOs that you link to one or more OUs. Then you can define GPOs and link them to lower level containers for settings that do not apply to all computers or users. Since OU GPOs have the largest scope, they are the easiest to implement and maintain. Start by reviewing your OU structure. You should ensure your OU structure realistically represents your functional organizational structure as closely as possible. OU designs that closely represent functional structures make it easier to create appropriate OU level GPOs that satisfy your security policy. For example, suppose your security policy requires specific application and object access for members of the Human Resources Department. If you define all users in the Human Resources Department in the HR OU, it is easy to create GPUs for the OU that affect all HR department users. Remember, too, that all security control design starts with your security policy. Once you validate your OU design and identify the controls you will need to satisfy your security policy, you can define the control scope. In the context of GPO settings, the scope of any control is the group of computers or users to which each GPO applies. Setting scope to the OU level should exist in OU GPOs. You can define any settings that apply only to some computers or users in local, site, or domain GPOs. You can also define limited scope GPOs at the OU level and use filters to limit the scope. You'll learn about GPO filters a little bit later. As a general rule, define GPO settings either at the lowest level, that includes all of the desired computers and users, or at the OU level using filters when the OU approach meets your needs. For example, you can define any settings that apply to all users for a specific computer in either a local GPO, site GPO, or a filtered OU GPO. The main difference is that Windows stores local GPOs on the affected computer and stores site and OU GPOs in Active Directory. OU GPOs also make administration simpler, since you define and link GPOs at a single level. Windows applies GPOs to all computers and users in a container by default. That means all computers and users in an OU will inherit any OU GPOs defined for that OU by default. You can change that behavior with security filters if you want an OU GPO to apply only to some computers or users in the OU. The GPMC allows you to add as many security filters for GPOs as necessary to satisfy your security policy. You can limit a GPO to users, groups, or computers. Once you define a security filter, Windows will apply that GPO only to subjects defined in the filter. This option gives you much more control over how Windows applies GPOs you define at the OU level. So here's how you define a security filter for an OU GPO. You first select and expand a domain in the GPMC, then you expand the group policy objects and you select a group policy object here, the password GPO. You select the scope tab in the right pane and then select add in the security filtering section, and then you have the option to change the type of objects and the location Windows uses to build the filter options. The defaults will allow you to select users, groups, or built-in security principles from the domain you selected before. You can select the Object Types button and select the Computers checkbox to define a filter for specific computers. Then you would enter the user, the group, or the computer name for this filter. You can choose check names to validate the object name you entered. Then you choose OK to create a new filter and you return to the GPMC. Windows Management Instrumentation, WMI, is the infrastructure Windows uses to maintain and exchange management and operations data. WMI filters give you even more control over when and where GPOs apply. You can create multiple WMI filters for each domain and then link each filter to one or more GPOs. You can link only one WMI filter to each GPO though. Windows evaluates the GPO's WMI filter before applying a GPO, and it proceeds only if the WMI filter expression evaluates to true. WMI filters allow you to query the target environment and apply security settings only in certain situations. For example, suppose you want to apply a GPO only for computers that are running Windows 7 Ultimate. You could define a WMI filter that will restrict the GPO to the desired machines. Here you can see that Windows uses the WMI query language, also called WQL, to define the queries for the filters. WQL is a subset of the SQL language that many database engines use to query data.
So to summarize, there are several steps that are required to create and deploy a GPO. First, you would create the GPO. For that, you would use the local security policy for local GPOs and the group policy management console for Active Directory GPOs. Second, you would define the GPO settings, which means that you would define and set values for your desired settings. You can define as few or as many as you want in the same GPO, but for maximum flexibility, you really want to define only the related settings in a GPO. Next, you would want to define any desired GPO filters.
because they will help you limit the scope of the GPO effect. And these filters make it easy to define groups of users or computers to which the GPO will apply. Lastly, you would link the GPO to one or more sites or to organizational units or domains. Linking a GPO tells Windows to deploy the GPO to the linked container. So once you link the GPO to one or more entities, Windows Active Directory takes care of everything else. Let's take a moment to consider why auditing group policy is so important. Once you design and deploy GPOs to support your security policy, it is important to validate your group policy to ensure that you have defined the right GPOs. Auditing group policy ensures the GPOs you have in place satisfy your security policy. As you change users and computers in your organization, you may find that your GPOs no longer satisfy your security policy. This is why it's important to audit group policy periodically to ensure that any changes in your organization have not reduced your GPO's effectiveness. Microsoft gives you two main tools you will use to audit group policy: Group Policy Inventory and Resultant Set of Policy tool. The first tool, Group Policy Inventory, provides an inventory list of GPOs and many other computer and user settings. You must download this program from Microsoft's website and install it on your computer. It's not included when you install Windows. The second tool is included with Windows. The Resultant Set of Policy tool shows what settings Windows applies to a specific user on a specific computer. This is the tool that you're seeing on the lower right-hand side of this slide. The RSOP, Resultant Set of Policy tool, shows the specific settings that will result from applying GPOs to a specific user logged onto a specific computer. The Group Policy Inventory tool can include some RSOP results, but the standalone RSOP tool provides access to a whole lot more details. So this tool is a great way to analyze the effect of any GPO changes. RSOP provides two modes of operation: a logging mode to show the existing GPOs and a planning mode that shows the effect of planned GPO changes. So here you see the logging mode. Group policy is an important concept of secure Windows environments. Many resources are available to help you follow established best practices for secure systems. Let's talk about a few of the recommended guidelines and available resources. While there are many ways to design group policy for your organization, a few guidelines can help focus your efforts. You might want to follow these guidelines to design a group policy that will minimize administrative effort while satisfying your security policy. Most importantly, don't make your group policy overly complex. Simplicity is always an asset in any policy. Keep your security policy and group policy as simple as possible while still fulfilling your goals. Here are a few additional guidelines that should result in simple and effective group policy. You want to define your OUs so that they reflect your organization's functional structure. Then you want to create GPOs for these OUs for those controls that are required in your security policy. You also want to use meaningful names for GPOs to make the maintenance and administration easier. Very importantly, you want to deploy your GPOs in a test environment first before deploying them to your live environment. Then you also want to use security filtering and WMI filters to restrict the settings when necessary. Of course, you do want to back up your GPOs regularly and really don't modify the default policies if you can. Instead, create new GPOs. This will ensure that your group policy is both effective and easily maintainable. You really want to only define and deploy the GPOs you actually need to meet the goals of your security policy. Extra GPOs will only complicate administrative tasks and may get in the way of completing primary business functions. The process of migrating from an environment with few controls to a secure environment can be frustrating for both end users and administrators. Make sure you test all GPOs before deploying them to a live environment. Conduct tests that will allow you to evaluate how each GPO will affect your users' abilities to do their jobs. New security settings that stop people from doing their jobs are harmful to your business. Be aware of any new policies that may result in a negative business impact. And when security requirements conflict with business requirements, it is up to the organization's management to resolve the conflict. The best security solutions always support both security and business concerns. There are several other resources available on the Microsoft website and its user forums to make designing and implementing group policy across the domain easier. Use these resources as well as the tools and resources you've already seen. They keep you from reinventing the wheel. They also provide input on solving issues that you may not have encountered yet. And now let's take a look at what it means to be working with group policy objects. First, you need a domain and a few organizational units to which to apply group policy objects. This slide shows how to get to the Group Policy Manager from the Tools menu in the Server Manager for the Active Directory domain services. You can right-click on the domain and set, as I have done, a master OU, which will later be connected with a master group policy. Under this master OU, I have built 3 OUs just by right-clicking on the master group policy and selecting New Organizational Unit. So as you can see on the right side of the slide, my finished OU structure is basically built as department and then computers and users. So my departments are finance, HR, and IT. Now IT is a department that has 2 levels of users. It has interns and it has system administrators. We have in HR an HR for East Coast and an HR for West Coast. And under these I have the computers because I want to align the printers with the West Coast and East Coast office computers. And then I also have my HR basic users here on the top level. And I also have HR management users who have special policies that apply to their user accounts and to their computers. Finance has a similar structure. For finance, I have basic users and basic computers, and then I have a management structure also set up under finance that has special group policies that apply to computers and to users. And those are my OUs. Under my master group policy, I have set up a group security group. This group security will hold all my groups, and these groups will then hold nested groups inside of themselves, such as, for example, the management group, which holds the finance managers and the HR managers, both of which deal with confidential information and will have specific group policies applied to them. Here you're seeing me using the overall administrator user template in Windows and copying this overall administrator user and their permissions to the IT system administrator group. This is important because it allows me not to have to reinvent the wheel. I am then on this basis going to build for myself 2 accounts. One of the accounts will be a more restrictive standard user account, and one of the accounts will be the elevated administrator account. Of course, the administrator account will only be used to perform administrative functions, and typically I will not log in with this administrator account if I have to perform basic user functions. Here you're seeing a basic user account by a user called Pretty Bready. I can double click on this user account in order to bring out the user account properties and navigate to the Member Of tab. In the Member Of tab, I can assign groups, as you're seeing on the right-hand side of the slide to which I am going to associate this user. And I can also right-click on this user and copy this user profile and rename it to simplify the setup for an account for an additional user. I have now created 3 users as IT interns, and one of our users, Yolanda Gutierrez, was hired on as a help desk associate, so has to change her group from IS interns to our IS help desk password group. Here is the process for doing that, and I should have created, and I did create that afterwards, an organizational unit for IS Help Desk with users and computers, and then I added Yolanda as a user by just dragging and dropping her into that new IS Help Desk OU. Creating OUs with groups and with users is basically the same process that you will use in order to add computers to your group policy objects. For that, you want to make sure the computers exist, and for that, you want to be sure that your DHCP and DNS are correctly configured so that you can connect to other virtual machines in your environment. There are 2 great videos that show you exactly how to do that, and these are listed right here and on YouTube. So now that we have our users and we have our computers, theoretically, we are ready to configure group policies. Here in this slide, you will see the default domain policy, which already contains a default password policy under Settings and Security Settings. I can now choose to either keep this default domain policy for passwords and also for lockouts, or I can decide to change the password policy, or I can decide to apply any kinds of filters based on the security situation. That would be a WMI filter, or based on the applicable OUs. This also includes setting stricter password policy parameters, maybe for some organizational units as opposed to others. The most important thing, though, is that I am going to work off of an already existing password policy in order to save myself the trouble of reinventing the wheel. Here you're seeing the process for editing a group policy, specifically the Windows default password policy. So you would right-click on the password policy here, select Edit, then the editor will appear, and you follow the steps that you're seeing here. The most important thing for a password policy is to always leave reverse encryption disabled, because otherwise your password will be stored in something very, very close to plain text, and that's really one of the things you don't want. After you have applied these changes, always remember to run gp update /force, because that will refresh the group policy after the changes, and it will push the group policy out to the applicable machines and users based on the system settings, the highest being 90 to 120 minutes. Of course, creating new, more granular group policy objects is always an option. For that, you would right-click on an existing OU and select Create a GPO. Then you would name that GPO and you would apply the settings to it that would be in compliance with your security policy. So here are a few things to keep in mind when creating group policy objects. You want to remember that GPOs contain computer and user configuration settings, and that they must be assigned to organizational units. And that means that you will have to build the organizational units before you can assign the GPOs to them. A GPO will apply recursively to all sub-organizational units and objects, and you want to be sure that before you work on creating a new policy, that there is not a default policy in place already that will do the very same job. So these are all the aspects of group policy that we have discussed. Thank you for checking in, and I really look forward to seeing you around next time.